Yes, thank
Next
you.
up, we have Mohamed Shebl, who will be presenting the effectiveness of bee pollination on the yield components of broad bean, Vicia faba in Ismailia, Egypt. So Mohamed, could you please share your screen? And Clement, yes, you can add your question to the Q&A box now, I believe. You should be able to anyway. All right, Mohamed, looks great. You can take it away whenever you're ready.
Okay, I'm ready.
Okay, go ahead.
Okay. Hello, everybody. I'm very happy to present part of our work. I am Mohamed Shebl, and I work at the Department of Plant Protection, Faculty of Agriculture, Suez Canal University in Egypt. And I'm going to present some of our results on the effectiveness of bee pollination on the yield component of broad bean Vicia faba in Ismailia, Egypt. First, I would like to start with the background and how broad bean is important for Egyptian agriculture. Globally, broad bean is the third most important feed grain legume, and it is considered one of the major cultivated crops in Egypt. It comes in the third rank after the wheat and rice. The total cultivation area of broad bean in Egypt in 2019 was around 40,300 hectares, which produce about 1,340,000 tons. Broad bean is self-pollinated crop. However, cross-pollination by insects, and in particular bees, have several yield benefits. Here, I would like to see what kind of problem, because the status of the crop production in Egypt has been become very bad. Broad bean acre has been shrunken from 1,800,000 hectares in 1991 to 32,500 hectares in 2017, which means that there is a low cultivation area, which means that Egypt need to increase the seeds. And what is the only source? Egypt or Egyptian policy is to import the seeds from abroad. So Egypt is the first ranked import country of broad bean worldwide. Egypt shipped around 3 million tons yearly of broad bean, which cost around 200 million from the time from 2005 until 2015. So with low cultivated area, we have low production, which means that we need to pay more money to get the seeds, which is consumed by most of local and poor Egyptians in the breakfast especially. So the problem here that we need with the current cultivated area to produce more seeds and to save more money for other important crops like wheat, especially. Important of bees for crop pollination in general, the economic value of insect pollination worldwide estimated at $217 billion annually for all ecosystem pollination services. Most Egyptian crops rely on the service provided by different pollinators, and the make values of Egyptian crops are available. There is not much published data or results about how important bees for crop pollination in terms of monetary, in terms of money, in terms of economy. But only one reference indicated that the total loss of Egyptian agriculture ecosystem is estimated around $13.5 billion Egyptian pound, equal 2.4 billion US dollar, due to the loss of insect pollinators. Broad bean pollination. Broad bean is a self-pollinated crop, but cross-pollination by insects have several yield benefits. Broad bean pollination is crucial for better seed production. The biodiversity of bees visiting broad bean flowers is very important because they can guarantee a good seed production. Bees of Ismailia are the most active and effective pollinator on bean flowers, especially those with large size. The importance of bees in broad bean and their impact of its production has been addressed in several works in several countries, but not precisely in Egypt. There is no any published results or any published data about how bees influence the crop and seed production of broad bean in Egypt. So this is was the question. How bees is important? What kind of species present in the in Egyptian agriculture ecosystem and could be benefited for the seed production of broad bean? So the hypothesis to do biological and ecological observation, which could help to understanding of the impact of bees on broad bean pollination under Egyptian conditions. The methodology, we did this study in 2 seasons, in 2018 and 2019. In 2018, we did this experiment in 2 different farms. We decided to choose 2 farms in Ismailia. One belonged to the faculty and one belonged to agriculture authority of the government. But unfortunately, in the second year, we couldn't find the second experimental farm. So we only did the experiment in one experimental farm belonging to the faculty. Here we can see that we did the different cultivated practices to cultivate the broad bean. In the first season, we only did an open and closed experiment in 2018. But in 2019, we started, after we get the data of the first season, to think to increase the number of bees visiting the broad bean. So we decided to do an intercropping or using border plants for attracting more bees and to increase the seed production. So this was the experiment done only on the next season. So 2018 only closed and open and closed pollination experiment. And in the second season, 2019, we did the border plants to attract more bees for increasing the production. We chose Brassica raba and Phacelia tensifolia. We collecting the bees and other possible flower visitors by using 2 methods. The first methods were normal sweeping net. We did many trips to collect several pollinators, several bean pollinators, not only in Ismailia, but only in other regions from 2012, even up to now. And also we tried to think about another methods to use Malai's trap and to see what kind of insects could be attracted by using this trap. Meanwhile, we during the whole season, the major species in Ismailia, we counted the total numbers of the species at 3 times per day to compare the species abundance through the whole day and the whole season. As I mentioned before, we did a pollination experiment, open and closed pollination, and also we studied the yield parameters, main length and number of green pods and green and dry seeds weight. Here, I would like to show the results, the broad bean entomofauna collected by Malaise trap. Here we can see in the 2 seasons that there are several groups of insects. We divided into 3 groups: pests, pollinators, and natural enemies. I would like to focus on one species in red, Andrina safignii, because Andrina safignii is a common species. It's found in Northern Africa and other parts of the world, but it's never been recorded on the broad bean flowers. It's only visiting plants of Brassicaceae. So we cannot consider these as the major pollinators of broad bean, but it might be found in the field during some weeds or some other flora surrounding the broad bean. We can see several species: Apis mellifera, Lysoglossum, Muscadi mustica, Surfidi, Coccinellidae. So we can figure out that maybe Malaise trap is not working functionally to collect the major pollinators, especially the larger sized bees. It might be working good with Coleopteran and Dipteran. Here, the rest of the species collected by sweeping, but not only from Ismailia, it is only from other regions in Egypt. We can find several long and tongued bees: Apis mellifera, Calicedomus saeculum, Andrina opatula, Eosira, Colitis lacunatus, Xylocopa pubescens, Lysoglossum, several species of Anthophora, Amygella, Hylaeus, Megaki. But the species in the red is the major species which found in Ismailia with a high number. Here you can see the short-tongued bees visiting broad bean. This species is Colitis lacunatus, one of the most common species in the area. And this one is Andrina ovatula, which also is common species and visiting not only broad bean, but other crops as well, but it works very, very good for the pollination of the broad bean. Several species of long-tongued bees, Anthophora aegyptiaca, Apis mellifera, and some other species of the same group of Anthophora. Here, another species, Calicedomus saeculum, and this is Xylocopa pubescens. The recent decline is known worldwide. So here I compared our data, our obtained data, with published data during 17th from various localities in Egypt. Here you can see on the left side, on the yellow, is the species composition found by us from 2012 to 2019. On the right side, in the black, the species found in 17th. Here you can see we find 8 species, but in the 17th, they found 20 species. So that means there is a real decline. But the most declined group belongs to the tribe Anthophorini. Most of the species are ground nesting, so maybe the land use and urbanization affected the presence and existence of these species, especially Anthophora atriceps, Cinericeps. Several species were abandoned in 17th, but it is not existed right now. Here, I would like to show you the impact of bees in broad bean pollination on the experiment done in 2018 in open and closed pollination. Here you can see the crop parameters, and you can see the real significant differences in the open and closed pollination. In the green bud weight, it was 1.25. In open pollination, 14. Dry weight, 4.2. 4. Bud length, 1.09. 11.5, bud number 0.2, 11.7. So there was a real significant differences between the open and the closed pollination. So now we can have the idea how bees are important for the seed production of the broad bean. So in the next season, 2019, we decided to maximize this production. So here you can see the bee species abundance with using the border plants. BBC broad plant plus canola, you can see here. BBC broad bean without the border plant in the middle. BBP broad bean with Phacelia quinquefolia. So here you can see how the border plants affected the bee species abundance and increased the number of bees visiting the broad bean. So we can expect that this will influence the crop with more seed production. Here we can.
I'm sorry, I'm gonna have to cut you off there as you're out of time. We have to move on to our next speaker. But if there are any questions at this point, I was hoping someone could put them in the Q&A or in the chat and you can address them there. So sorry, I have to cut you off.
Stop or continue?
You need to stop, please.
Okay.
Thank you so much, though.
Okay, thank you.
Perfect, thank you. And then I think, Peter, you weren't on before, but are you on now?